Good afternoon, everybody. Well, afternoon at least if you are living the Finnish time. And a warm welcome to the Aalto University's public lecture series. And as you know, the theme is the future of technology and Finland. This is the second lecture what we are having. We were having excellent lectures last week, and I am sure already that we will have excellent lectures as well this afternoon today. My name is Jarno Limnell. I am the professor of practice here in Aalto University and concentrating especially the security and cybersecurity issues, which are of course part of this technological development as well. Some practicalities, very short. First of all, please unmute your mics when and hopefully when you are having questions, comments, please use chat. That's very easy to use, and then I will pick few of your questions also and present those to the lecturers after the lectures. To our students, please verify your presence. You will find a password given by Juho in the chat very soon. Well, actually at the moment. And then you have to go to the My Courses and use that code over there in order to make or verify your presence. But like I said, warm welcome, and warm welcome also CEO and President of VTT, Antti Vasara. Good afternoon, Antti.
Good afternoon, Jarmo.
Hey, sorry, I have to ask, what is VTT in English?
It's just VTT. We don't translate it, so it is that. But we call generally these things research and technology organizations, RTOs. So
yes,
that's how they are called in Europe. But VTT is VTT.
And I have to say that when I was asking you, and thank you very much for joining this public lecture series, and when I was asking you to give this lecture, I was changing emails and discussing with you about this theme, what you have been presenting and saying also publicly lately, this like a five exponential hope and technologies. If I may ask, why you are talking about hope?
Hope is something that we all need. I think that we need it at the moment a lot because everything seems to be about pandemias and crises and those kinds of things. But when you see that what is cooking in science and technology at the moment, I think that hope comes very naturally because I think that we have such a fantastic time at the moment in our hands that we can solve these challenges, and that's what I want to talk about today and pick a few areas where I see that science can really provide answers.
That's what you are more or less on daily basis thinking about in your work.
Yes, that is what we do. And of course, we have 2,000 colleagues who are. I'm standing on their shoulders here during this lecture. So this is sort of. I'm just channeling the thoughts that they are having and the work that they are doing. But I think that we think that there's a lot of reason for hope.
Very well said. Hey, warm welcome, Antti Vasara. Please, floor is yours.
Thank you, and I will now try to get my slide showing. So, as I said, I'm CEO for VTT, and we are a 2,000 person strong research organization, and what we of course, our daily work is researching different types of technologies and scientific areas. But what gives relevance to the work that we do is that we want to find these big questions, these big challenges that are out there, and find solutions to those, utilizing the research and the work that we're doing. And that, I think, is a really something to think about also, in terms of that when you think about science and technology, we're very easily immersed in the and especially experts go very deep into the technologies and to the details, and that's how, of course, you get the things done. But at the same time, then to always try to reflect on then that, why are we doing this? What is the relevance of this thing? And the relevance comes from then that we can really produce things that push mankind forward, but also then give us hope. And that's what I want to be talking about today. Now, without being too cliche, I think that the next decade, the decade that we are living now, will be a very pivotal time in history. There, of course, every decade there have been big things happening, but we are facing really big challenges. We have sort of really hairy, nasty challenges that are very systemic in nature, making them very complex to solve, like climate change or resource depletion and these kinds of things. We are still living through a time that, although we start seeing then the negative effects of these type of things, but at the same time, we still have time to react. But we are early in the curve that most of the time we don't notice the early effects of these things that severely in our lives. And it is very human then to be thinking then that, oh, I have time then to start addressing these things later on. And now during this decade, we will define then that how difficult it is going to tackle these challenges. And we will basically have to either spend a lot of money then later on in solving these things, or pardon my tough language here, that all we will pay it in human lives and sort of the welfare of humans, or we can start paying through acting on these things and utilizing science and technology then to early on change things, so that there will be a positive future for us, but also then future generations. And I think in Finland especially, and in many countries in Europe, we are very forward-looking in education. We have excellent technological expertise and also sort of the awareness of these things. So we are in really good position then to be utilizing this moment and making a real impact. I think that we were all very much woken by the pandemic and COVID-19, that how quickly a crisis can happen and how quickly things can turn. Almost overnight, our lives went in from sort of a normal day-to-day things into radically different. And in a way that I would say that it is a big shame that if we now kind of like recover from this crisis and not come out of it by being better than we were before. So in the sense then that how we can use these type of crises as a way of renewing things, even radically sometimes, but improving all the time for the better. And when I'm talking about this, of course, I am in no way downplaying the human suffering that has been caused by the pandemic and loss of life and also the economic things. So those are, of course, the key priorities to address and making sure that both people's lives are safe and also so that the livelihood of people. But at the same time, it is then that when we are in a situation like that, we need to look for opportunities that how do we now support then the long-term well-being, start solving these systemic problems and utilize these types of disruptions as a way of then tackling the hard problems, and also then that we are all the time keeping in mind that we need to do growth sustainably, and think about then that this is really a long-term race and not sort of a short-term sprint, maximizing that what we have now, but finding ways that how we grow sustainably. And in here, I don't think that you're surprised that if I or when I say that I strongly believe then that the key to many of these things lies in what we can do with science and technology, both in creating the sustainable growth, but also then the hope, and in a sense that when seeing that what is at the moment already possible in the laboratories at universities or research institutes like VTT or some companies or startups, that is the thing that gives me then hope that we can tackle these things and get really ahead of the curve in terms of then that taking control of some of these changes. And that's where then the idea then came to basically bring forward a few areas of what we're calling exponential hope here, meaning then that, hey, we can be concrete and also kind of like showing then that what is at the moment possible and what can then happen as a result of that. Exponential here means, and exponential is of course a very widely used term, but exponential here means then that this is not sort of an incremental change that what a certain technology can create or certain area can create, but the real paradigm shift that you really kind of like jump to a different level so that you see a real performance gain or productivity gain or sustainability gain. And at the moment, kind of like looking at what's happening in many areas, we can see that it's not only one area that where we are seeing sort of real exponential growth, like in the old days, it was steam engine happening, and then kind of like that created the industrial revolution. But it's happening on so many different areas. Hope, as already discussed, then that I think that we all need hope in terms of then that the kind of like that how the news address these issues, and what is sort of comes naturally is then that we are extremely receptive to bad news, and we can see all the negative and kind of like the doomsday scenarios of these global challenges, but we can actually tackle these challenges. And also while doing that, we can then also create well-being jobs and sustainable growth. Sort of then that not only are we taking care of the challenges, but we are also making sure then that the society, companies, people are doing better than before. And that's kind of like where it comes then, that kind of like combining these things together, that if you start looking at what is possible, also your hope can grow exponentially. And of course, that's not a scientific term, but it is a sentiment that I hope that you will share with me and us. So the areas that we picked are 5. Biotechnology in food production, quantum technology, small nuclear reactors, chemical plastics recycling, and optimization the use of materials. I on purpose wanted to have a short list. So these are the 5 ones that we have picked, and as many people have already commented that there are brilliant areas outside of this list of 5 that would deserve to be here. But since in order to keep the list short, I had to make choices, and these are the ones that we picked to basically kind of like introduce areas that are perhaps not that well known in the common discussion, but also then that where we from our own work know that things are really progressing in an exciting way. So by choosing these, I am not saying that other areas are uninteresting, but this is the focus here. So let's get going. So first one I've picked around food production and how to use biotechnology then to enable sustainable growth also in the food system. So why is this relevant? A really big challenge for mankind will be, and already is and has been, is how do we feed the growing global population? And that's sort of been the story of mankind for many thousands of years, and there have been different phases that when farming started, and then sort of more industrial scale farming and agriculture has really started to grow in the past 100 to 200 years. But we are seeing the limits of that how to feed the global population, ever-growing population, and making sure that everybody has healthy food, but also then that we are starting to test the limits of the planetary system, that how do we minimize the negative environmental impacts coming from the scale of food production. The food productions, what is being done there is per se not the problem, but the scale that is needed is the problem, and we need additional things in here. And one area which is really promising is what can be called cellular agriculture or single cell agriculture, that how you use different types of single cell organisms, microbes, plant cells, animal cells, and the tools and trade of biotechnology to produce food instead of kind of like just having animals on fields or sort of the traditional agriculture. And what we can do here is then that we use them, for example, microbes, then into turn different type of feedstocks into sustainable food ingredients. And I will be using as an example here in this presentation, for example, how you can create egg protein without chickens, or milk proteins without cows. And the benefit coming from this is then that being able to produce additionally food in a sustainable way, where also the environmental footprint is smaller, but also then that how we can scale cellular agriculture in a way that it's not increasing the land usage and the environmental effects of that, but also in a sense then that leaving room for traditional agriculture to produce more food for humans instead of animals, as it is happening at the moment. What this could then mean in practice is this example, eggs without chicken. I'll come back to that one. So kind of like producing certain type of proteins using biotechnology. We can also kind of like create sort of sustainable foods from the microbial mass itself. Corn is one example, solein from solar foods. Do this vertical farming instead of the horizontal farming, which has beneficial effects, but also then that the food production can be done in totally new places where it's not possible at the moment. Deserts, space, and even kind of like if you think about then that during the Finnish winter, certain type of things are just impossible to do here. So in a sense that also make certain type of agriculture then possible all year round, also in our climate. This case example here, where to dig a little bit deeper is this what we sort of calling eggs without chicken. Egg protein is needed in very many foods, and especially if you're allergic to eggs, you notice then that how so many foods that you can buy from store actually have egg protein in there. And quite a large chunk of the eggs that are produced are used only to get the albumin, the egg protein that's used to kind of like give structure and certain type of characteristics to food. So what if you could produce that protein directly to be used then in manufacturing foods? That could have a really big impact on both on land usage and these types of things, but also then the amount of greenhouse gases being emitted and other type of positive things. So these are very promising things, and kind of thinking about how to then use these as a way of scaling up food production in a way that doesn't then overburden the planet. Why this then makes sense in Finland, and why we are excited about this as an opportunity for Finland. So we actually have very high level expertise in many areas, technology areas, food areas that are related to this. I think that the Finnish consumers are open-minded for new food innovations, and in that sense then that this would be a good jumping ground, or kind of like a building ground for new companies then to start testing their ideas and then going abroad. And this is also kind of like then the overarching theme in all these 5 areas here, then that research is generating ideas, research are generating possibilities, and then we hope then that companies can pick up from the work that universities, research organizations are creating, and then turning them into commercial innovations and really kind of like make the impact happen and create the jobs. So moving swiftly forward, quantum technology is an area that kind of like well, I used to study, or I did my studies in physics, so this makes me really excited about seeing then that what can be done with quantum technology. And where the promise there lies, and the kind of the challenge that we can solve here, is that if you think about what transistors, microprocessors, modern day computers, mobile phones, these types of things have enabled, they have been absolutely instrumental in so many different fields. And you could say then that the invention of transistor has been the basis for modern day wealth and well-being. And now we are seeing then that kind of like that we're basically hitting the laws of nature in how to all the time keep on improving. We have been blessed with getting all the time more and more computing power every year, and now we are starting to see then that although there are still many things to do on that front for years to come, we are seeing that it will start to plateau. What if we could then do a giant leap in performance and jump to an entirely different level? So in the same way as transistors and microprocessors and computers, if you were using an abacus before, then a computer is like magic, what you can do with that. So what if we get many orders of magnitude improving that what we can calculate, what we can simulate, and what type of problems we can do? And this could really unlock then in many fields really rapid development. So we could develop medicines and vaccines, or new types of materials, really kind of like bring forward artificial intelligence and these types of things. And sort of the possibilities are really endless. And what this could mean is then that the world around is quantum physical. So if we can harness then the kind of quantum physics to do the calculations, we can then, or at least we believe at the moment, that we could really then simulate that what happens in molecules, chemical, biological processes, different type of materials, and start designing these materials and proteins to be what we want. We could have absolutely unhackable internet, quantum internet, or at least unhackable through current means, and in that way also sort of make sure then that the benefits that we are getting from communications could be also utilized in the future. And then what has already been used for a while, then that the kind of doing sensors and sensing applications based on quantum technology, like brain scanning has been done for some time with essentially quantum technologies, and many other applications there as well. And why this type of thing makes sense in Finland? People are reading in the newspapers that China is spending tens of billions of euros in quantum computing. The same in US, Europe, Germany. These type of places are spending a lot. But actually, even though that we don't have the billions to spend here, we have long-term expertise in electronic superconducting circuits and these types of things which are required here. Aalto University, or the former Helsinki University of Technology, had housed the low temperature physics laboratory, which was pioneer in its sense, in its own area, but that has led then into development of many of these areas where we can actually then make progress now and develop quantum computers. And what this could mean then in Finland is that we could create a new expert industry around building different type of either quantum computers, the sort of full quantum computers, or then different types of subsystems and components. And there are already startups and companies operating in this field. And this is similar to then that even though that we didn't invent the transistor, we have created a very thriving electronics industry in Finland that has then went into essentially to all different domains. Then we can also then utilize quantum computers as a tool then to solve things. What can be, for example, done with quantum computers, or at least what we at the moment know that can be done, is then this modeling of really complex molecules or really complex systems at a level that is just impossible with classical computers. And this would then enable many of the current industries that are operating in pharmaceuticals or materials science side then to get tools how they can take their product development then to a totally new level. So, moving swiftly on as the clock is ticking mercilessly forward. Next challenge that we want to tackle is then clean energy. And one thing there is that we know that we need clean electricity, carbon-free electricity, and actually in Finland the situation starts to be already quite good even today. But then we also need to create clean heat, which is needed both in district heating, but in most of the industrial processes that are done in the energy intensive industries. And we believe that there are, of course, multiple ways how you can also create carbon-free energy, but a key piece in the puzzle will be small nuclear reactors. The small nuclear reactors are basically they are sort of normal nuclear reactors, but they are used slightly differently when they are producing heat than when they are producing electricity. Essentially, nuclear reactors are gigantic water boilers. So they're like the kettle that you use, electric kettle that you use to warm water for your tea. So they boil water. Now for electricity production, then you need to be using that hot water then to transform. First you transform the nuclear energy to heat, then you transform the heat to mechanical energy, and then the generators change it then to electricity. So there are many steps. But if your end goal is to produce heat only, then you get it straight from the nuclear process. And that means then that actually these type of reactors can be made a lot more simpler, not a lot more cheaper to manufacture, but also then that from their safety features to be also extremely safe, as the systems are quite simple to build. And this means then that we could be building these type of small modular reactors in a scalable, almost industrial way, and building these modules that can be used then either in industrial processes or in for example, district heating. And the size of these types of things are sort of, it's an industrial hall, so it's not kind of like a tabletop device, but still that they are in a size then that they are kind of comparable then to, for example, to the current district heating power plants that are out there. But these would then generate at running time completely carbon-free the heat that's needed, district heating or industrial uses, or they can be also used then to generate hydrogen. Hydrogen is a great way to store energy, so both for solar and wind energy, but also then to be turned into these so-called synthetic fuels, so then that they can be used then in conventional engines. So and many other benefits here as well. But this is sort of an area also again that would make sense for Finland, because we have very ambitious carbon neutrality targets. So we really need to do something about the CO2 emissions of our heat generation. We have a long tradition of doing safe nuclear energy, and also actually we have the knowledge both on the research side at the universities, but also in companies then that how we could build these type of nuclear reactors and turn this also into a export area. In the interest of time, I rush forward. There would be so many things to say and too little time. I move to the fourth area. And this is important both from the circular economy point of view, but also then to tackle the other environmental problems that we have also in addition then to greenhouse emissions. Plastics are a really useful material. They have been you could say almost a lifesaver in improving food hygiene and eliminating food waste, and in so many different areas, because they are cheap to make and easy to manufacture and easy to mold into different type of shapes. The trouble then with the current way of using plastics is then that globally only 10% of plastics is recycled. In Finland it is 25%. But the recycling of plastics is very difficult at the moment, because usually most that can be done is mechanical recycling, where you basically grind it into grind the plastics into smaller pieces, and then use that material then to make at the best similar quality plastic as before, but each time it's recycled, the quality of the plastic degrades, so that in the end it can only be used for burning. And what we need here is now a rapid increase in the recycling rates. In Finland, the target is that by 2025, 50% of plastics should be recycled. It's only 5 years to go, and we need to get from 25% to 50%. And mechanical recycling doesn't cut that target. So in that sense, then that we need to do something very quickly. Chemical plastics recycling basically breaks the plastics down to its building blocks. It turns them into monomers or molecules, small molecules that can be then used as a raw material again to make new plastics. So that's how you really get the circular use of plastics happening there. And of course, this has been known for quite some time, but it requires a lot of energy, and basically the economics haven't been working there. But when you both have to take into account then the environmental hazards that are coming from not recycling the plastic, it's ending up in all the wrong places in many places of the world. The need to reduce greenhouse gas emissions and the use of fossil raw materials, and then improving technologies, then suddenly this becomes actually relevant. And what can be then done here is then that firstly just basically being able to kind of generate high quality plastic materials sort of replacing sort of fossil raw materials and creating still materials that are equally good, but also then that the utilizing new streams of waste plastic that in the past have not been able to use as a feedstock anywhere, and this kind of like this would absolutely have then the positive effects. And again here, now I know I'm repeating myself, but here again we believe that this is an area that can be turned into an export industry for Finland. So of course we can solve the issues here in Finland with this, but also then by combining the knowledge that we have in the relevant fields like thermochemistry and biotech, and then the knowledge about kind of like doing, for example, industrial scale gasification pyrolysis, which are the technologies that we think that are extremely promising in here. We can turn this into also an export industry. How to take these type of industrial scale plants, then sell them elsewhere, but also then that we have expertise about collection and recycling systems, and how to organize that. So then that kind of thinking about the totality, the system here. And so far, for example, if you look at some of these areas, then that in food packaging, you end up combining many different types of plastics together to get the desirable features there, like then that the plastics can stop the water leaking through, but also then that it provides an air seal there so that the food stays fresh. But the fact from using many types of different plastics, it then leads into having very difficult to recyclable plastics, and this could be then recycled easily with a chemical means, and this would be an absolute breakthrough in terms of also getting then the recycling rates up. Last but not least, before I run out of time, optimizing material use, but also then that kind of like that, how do we start designing materials that have those type of characteristics that we want them to have, instead of just then that kind of like that what we know that comes from a process if you do the steps. Now, this is a very broad area in the sense then that we see many types of challenges that we need to be starting to use materials that are easier to recycle. How to enable circular economy requires also then that the products are designed and the materials are designed for circularity. Also then that we see that we have certain type of environments and kind of like building certain type of machines that where we need materials that are more durable or have certain type of performance criteria, and kind of like it's basically trial and error to try to find those things. But what if we could design the materials digitally, so using both computer simulations, physics, chemistry modeling, and in that way create exactly the type of material that you want, and be able to then produce it with additive manufacturing. You could then minimize the use of materials, maximizing the performance, but also maximizing the recyclability, and in that way also we think that we can minimize that how much Earth's sort of the growth in the resource usage that's happening due to growing population. And this means then that both sort of advances on the circular economy side, but designing these types of materials that exactly have the right type of performance. Now at the moment we already have those type of tools, and for VTT we have customers utilizing those type of tools, but think about then that we're now utilizing sort of a, you could say, microscopic level technique, so we're not getting down to the real quantum mechanical behavior of the materials and kind of really getting into that what's going on there. But think about then that when we can get quantum computers for these boys and girls who are doing the work at the moment, And then we can really start designing materials that would be unthinkable at the moment. And again, here, I think that this makes a lot of sense for Finnish industry to be looking at, because basically we have lots of companies that have excellent knowledge on material science and engineering. We have universities, research organizations that can do the modeling and starting to do the materials research, but also in a sense then that we have industrial companies building heavy machinery and these types of things that where the benefits from these type of high performance materials can be also utilized immediately. And we have large companies like Metso Outotec who are already in this business and have a global scope. So again, here it's a great place for both startups and existing companies to start generating the business. So to wrap it up, then these are 5 areas which I went through extremely fast, that where we can see then that we can utilize the science to create businesses for future. This is sort of like the famous Wayne Gretzky quote that don't skate to where the puck is, but skate to where the puck will be. Science shows you that where the puck will be. Now, hopefully in Finland, we are now kind of like tackling these areas and many other areas outside the list of 5, and start putting both the sort of this to the center of both the innovation policy, but also industrial policy, but also then that companies are excited to do this work and create the jobs and the prosperity in Finland, and starting to build their research and product development and innovation work here. This is a choice that we can make. We can either complain that there are so many challenges and the future looks grim, or we can actually act on it and do something about this. And that's where that's where my hope and optimism is coming from. Then that we can do this. We have both the science and the technology to do this, and we have the companies here. So hopefully we are smart enough now then to act on this and create something great for the future. And there I finish before I run completely out of time. Thank you.
Thank you very, very much, Antti. Excellent presentation. And I have to say that in my head, there are lots of thoughts. And I really like also that I think it's much more easier to talk about the future of the technology, to discussing about the different threats and risks and some bad issues. But I really like this main theme, what you are having, that when we are utilizing technology in the right way, it actually brings us hope in a great way. But what would you say? We have a lot of students also listening at the moment, when they are thinking about that, okay, they understand this development of technology, different aspects of it, and probably they are thinking about that, okay, what kind of skills I need in order to succeed and survive in this omni-technology present world. What would be your best guidance to these students?
So of course, many of these areas are kind of like heavy in technology and science, and kind of like if you want to build the inner workings of a quantum computer, it really helps to understand quantum mechanics and those kinds of things. But then when you expand from there, that machine, the quantum computer doesn't alone solve anything. It has to be utilized, it has to be understood that how it's used, and you have to understand the challenge that is being solved. So in that sense, then that all of these areas, even if I didn't have time to kind of like really kind of start expanding on these things, require that there are people who understand humanities, how humans behave, can help in making the sort of the ethical choices that need to be made. So these are all extremely broad-based. So in that sense, then that kind kind of like studying basically everything is useful. You can't go much wrong there, but it's how you want to apply it. And that's a choice that you only can influence. That then, that are you curious and try to understand? Are you curious then to walk to the next door laboratory where they're doing something strange that you don't understand, but ask them that what they're doing and kind of like thinking about, okay, how can we utilize this? And that type of curiosity and broad-mindedness, I hope that the students of today will have. And I was too narrow-minded. I was too much of a physicist when I was studying, that I was kind of like only in my own box. And that's the advice that I would give it to my younger self, to be kind of like looking broader and being curious.
Excellent point to students, and also to us a little bit older ones as well. So in a nutshell, you are saying that actually the next technology trend is humanity, and about ethical choices what we are making. Hey, I will raise two questions from the chat, Antti. First of all, a quote, so if you produce eggs and milk without animals, what will happen to our society and economy, especially the rural areas? What will happen to them?
So I don't believe that eggs and cows will go anywhere, but it's basically a question of then that if everybody at the moment on the planet would be eating eggs and milk as we are doing here, we would run out of planet. So that's the point, is then that how do we make also normal agriculture sustainable on this planet without basically asking half of the population to be without it and half the population having it. So in that sense, then, that this is about sustainable production, and it's of course a larger thing. And I didn't go, of course, into kind of like the systemic thing there. Then the other thing is then that who is saying that tomorrow's farm is going to be only about having then the fields there? You can also start kind of like then doing this type of vertical farming there and at the farm. So this might be also then that the way that the farmers' livelihood changes in the future. So we don't know yet, but these are the things that we need to keep in mind. But I believe that it is an evolution that will lead into good things for all.
Very good. Then that question was from Anna Pursiainen. Then there are a few questions concerning about the recycling. And if you have time, Antti, would be great if you would comment them in chat just after a while. But hey, one more question. I think this is very good one also from Kari Heiska. If you have to select one out of these five, what would you select for a success story for Finland during this decade?
Yeah, it's kind of like which one of your 5 children you love the most. I sort of now all of these are exciting. So in a sense then that they have different type of risks and different kind of difficulties. So I believe that all of these 5 will lead into commercial success already during the 20s. But it's also possible then that like in many areas of technology development, we underestimate the impact, but we are over optimistic about the schedule. So some of these might take a lot longer to solve, but then the impact is even bigger. So I'm I'm trying to evade the question because I can't pick that one from out of the 5. All of them, and I also believe that we can do all 5. It's not
you love equally all of your 5 children.
And also then that I think that we can afford to invest in all of them, and we must invest in all of them. So people are rightfully worried about Kaipola and Naantali and kind of like what are happening then to the industries that where there is a sort of a disruption happening from the market side. So how to replace these is then that we need to have lots and lots of new new buds growing, so then that we can have them successful industries creating the jobs then in the future.
Excellent. Thank you very much, Antti. Excellent lecture, like I said. And like I said, if you have time, please look at the chat,
I will.
the questions and comments, what has been putting over there. So we will go forward. This today's second lecture is CEO in Technology Industries of Finland, Jaakko Hirvola. Welcome, Jaakko.
Thank you. Thank you. It's a pleasure to be here. Thanks for the invitation.
It's our pleasure that you are giving your precious time to us and
we'll
share
see.
Your thoughts. Hey, after listening, Antti, I have to say that how hopefully you look to the future.
How hopefully do I look to the future?
Yeah.
Very much so. I think the future is very much in our own hands, and representing the technology industries. I believe that we have a lot of solutions that we can play with to make the future much brighter than many other people think.
I think we are having a great hopeful atmosphere here today. First speaking, Antti, about the hope, and then your title is Technology Industries New Normal, from COVID crisis to growth. It's something very positive. So please.
Thank you.
Please, Jaakko, floor is yours.
Thank you. Let me share my screen here. Thank you, and good afternoon or evening, everybody. It's good to be here and speak about the new normal of the technology industries. I noticed there were some familiar names in the audience, so I'm expecting very tricky questions after this. So please welcome, all your comments are welcome as well. So the title is Tech Industries New Normal, from COVID Crisis to Growth, and this is based on a scenario work that we did in our organization to trying to understand what the future might bring now after the COVID event, and the event is I should say just only started, so it's yet likely to take a lot of time until we are over with it. So I'll briefly look into where we are now and how we move forward. But first, just brief introduction to technology industries. What do I mean by that? So it's a combination of sectors that you can see here, representing 50% of total Finnish exports. So very much we are very much dependent on. I mean, the whole Finnish welfare system is pretty much dependent on the success of the technology industries sectors. 2/3 of the private sector research and development innovation funding is coming from this sector, and the industry employs 320,000 people directly, but the indirect impact is equally big. So it has a major impact in the Finnish society. Now, understanding what the industry comprises of, we have subsectors: mechanical engineering, which is the biggest one. Companies like Kone, everybody should know that by brand name. We have electrical and electrotechnical engineering, so companies like Nokia, metals producers like Outokumpu, SSAB, IT companies like Tieto, and consulting engineering companies. So 5 fairly different sectors. The first 3 ones are very sort of industrial, and the last two more service oriented. All in all, are 1,600 member companies, and it's worth noting that more than 90% of these are small and medium-sized enterprises, despite the big names that I listed. So where are we now? If I first take a few words about what the situation is now, then after that have a look at what options do we have, and introducing the scenario work, and then introducing our, let's say, the favorite option that we are striving for a bit more in detail, and lastly look at what are the sort of enabling factors that we need to have in place in order to succeed in this sort of hopeful journey that we are starting here. And as noted, I'm really positive about the future, but it requires some actions from all of us. So where are we now, looking at the tech industry's point of view, and maybe just a quick reminder that the Technology Industries of Finland is an association representing the employers listed in the previous pages. So what everybody knows is that we negotiate the collective agreements with the unions for those companies. But in this context, it's primarily, you could say, this is a lobbying organization trying to impact the policy making and make sure that we have a favorable industrial policy in place so that we can make the Finnish industries competitive. So where are we, or actually beginning a bit further before, where were we before the crisis? During the last few years, we saw the Finnish cost competitiveness getting a bit better, but now it's getting worse again. The graph on the right shows the unit work labor cost development compared to Eurozone in yellow, and compared to developed trading partner countries in blue. And you see that the cost of the Finnish labor is getting more expensive compared to our competition. That's a challenge, of course, because we need to be competitive on the global market. We are very exposed to the global market. Now, cost is not everything. Productivity is equally important, and you might argue that even more important, and something that we can do a lot about. Now, looking at the industrial productivity development, it's not satisfactory, but it's okay compared to the whole Finnish development, which is in orange in the graph, and the tech industries in purple. So we see that we are sort of the direction has been right anyway. What has been a major challenge in the tech industries and in Finland more broadly is that we had a long decrease period since the collapse of Nokia mobile business. So since the financial crisis, you see in green the research, development, and innovation funding going down year by year, and also the fixed investments is more or less flat. And if I would compare that with the depreciation of the fixed assets, that you would see that the fixed investments is less than the depreciation across the years, which is definitely not a good trend. Something positive, we are consistently noted as an innovative economy, and we have a lot of strengths related to that we can play with. According to Bloomberg, we are number 7 in the list of most innovative economies. However, we are moving down. We were 3rd, I believe, last year. So anyway, it's a good position to be in. So that's where we are sort of before the crisis, and when the crisis hit, what happened? and now you see only red dots. There's nothing much positive about that. So what we saw, well, first of all, it's worth mentioning that the tech industries is rather the development is a bit delayed compared to service sector. So the collapse is coming later than in the service sectors, but it's clearly now in our hands at the moment. The demand globally and across Europe has collapsed, and you see the change in RFPs in the graph to the right, indicating that we are sort of approaching the rock bottom figures in 2008 and 9. Our member companies, half of them say that according to their figures and assessments, the worst is yet to come at the moment, so the game is not over. 1/3 is laying off people. We just announced that we are likely to see 10,000 jobs destroyed during the autumn because of the crisis, and there's a number of bankruptcies expected as well. So rather pessimistic view at the moment. So because of this sort of serious situation, we wanted to see that, okay, so this being the situation and the demand probably not recovering very quickly, and the demand will probably be a bit different moving forward during the next few years. How should we go about looking at the future, and what options do we have? So what we did, we had a strategy project with Accenture Strategy, looking at the situation that we have, not only the COVID status and the COVID scenarios, how the virus would be spreading. Of course, there are different scenarios for that as well, but looking at also global factors, and particularly the global economy and the impact on the Finnish sectors and businesses, and thereby coming down to what the whole overall impact would be on Finnish technology industries. To understand the scenarios, let me first go through the framework for analyzing the impact we used. It looks a bit complex, but let's take it piece by piece. So on the left, you see the COVID impact. So understanding the illness cases, trends, safety measures, and restrictions. The restrictions are really crucial in the globally working businesses. How freely can our maintenance and sales people work across country boundaries? That's a relevant question. Of course, it has to be safe, but it has to be also smooth. Then in the middle, surrounding the individual technology company, we see on the top left corner factors related to the global trade and economy. We see signs of protectionism. We see varying signals about state stability in various continents, fluctuation in exchange rates, countries behaving different ways, some giving strong export subsidies, for example, reactions on consumer taxation and so forth. So looking at holistically on the global trade situation and possible development trends there. On the top right, the demand picture, what happens in China, what happens in US, in Russia, other, so demand and trust in economy. Several concerns raising from all these countries, reflected also the ability to cooperate with EU and affecting the demand behaviors and demand trends with the Finnish export businesses. Majority of our technology industry's exports is going to Europe, which makes EU, of course, the most important continent. About 70% of our export is directed to Europe. On the bottom left, we see the business environment of the company. So are factors that have a big impact. One is the competitiveness that I already mentioned earlier, the challenges that we have there on the labor market. So need to be a fair, level playing field with the other countries. Issues like trusting the financing system, stock market, nervousness on the market as a whole. And on the right, taxes, funding, and financing of the companies. So policies by the decision makers, politicians, on factors like corporate taxation, public funding, financing. Now we see these stimulus packages offered generously across all countries, and that of course has an impact on, first of all, saving some companies, but also to some extent twisting the market to something else than purely market driven open market. On the right, we also look at the renewal possibilities, not quite as future-looking technologies as Antti listed, but basically the digitalization of everything. Of course, one impact from COVID has been that digitalization has been boosted across countries and particularly on individual level, but also on corporate and company level. Sustainable development is something, particularly when it comes to climate change mitigation, that's such a strong trend that it can't be neglected. It has been a bit overshadowed by the COVID crisis, but it's a really strong trend that is affecting everything we do. So that is clearly a strong renewal trend. And also reflecting to the EU funding and the stimulus packages, we see that there's a very strong focus on digitalization and climate change mitigation. So this is the overall framework, and then at the bottom we have activities by which the companies can manage the COVID impact, but also activities that the politicians can do by making good decisions on the business environment. So this is the framework. Now looking at the drivers of the renewal, digitalization and sustainable development, mentioned as the strongest one by the project team. Now, as mentioned, the COVID has already strengthened the digitalization trend. Climate change is there, high on the agenda anyway, and we see the drivers supported by EU, as already mentioned. So Green Deal, the 7-year budget of EU, and the stimulus packages, the next generation EU package with the resilience and recovery package, which is 750 billion in total on Europe level, and something like 3 billion will be given to Finland. So how we use that money, that 3 billion is an interesting question in Finland, but also how do we get access to the stimulus impact across Europe, where 750 billion will be spent on making the economy run again. So do we have a competitive edge regarding the renewal? Looking at some factors here, how we in the analysis saw the situation. We are again the leader in the digitalization DESI index. What does it mean for businesses? What does it mean for small and medium-sized businesses? We are forerunners in 5G and 6G, so basically all this capability is in Sweden and Finland, in Ericsson and Nokia. Can we leverage it, combining that with the industrial digitalization? Very, very acute and practical question. We clearly have lost the business to consumer game already to the global giants, but the game is very much open for when it comes to business or government to citizen or even machine to machine level in the industrial play. We have a strong commitment in across the Finnish industries, and particularly in the Finnish tech industries, to commit to the carbon neutrality target by 2035, as stated by the Finnish government. We signed that commitment as well. As a practical exercise, we have done low carbon roadmaps for various industries, including ours, which seems to be an EU best practice. We haven't seen similar roadmaps done anywhere else, but now we have a clear common view of shared by the policymakers and the government and the industries about the carbon neutrality target and the activities on a high level, which is a real strength for Finland. Now, this is a bit complex, but I just show how Accenture wanted to look at the digitalization capability using the digitalization index, the DESI index, where we are the leaders. They took the factors out from the DESI index, all the factors that are related to businesses, companies, digitalization capability. And if you look at the graph on the right, you see that the gap between Finland and the rest of EU is even widening. So their message is clearly that this is a really strong capability that we have to be proud of and leverage that in our future for our future success. Keeping that in mind, looking at the scenarios, how these were made. And briefly, I don't want to go through all the drivers that we have here, but just looking at briefly what they are on a sort of a title level. The severity of the COVID virus illness is one driver, of course. Then we have a number of drivers related to the global trade and economy. We have a number of drivers for demand and trust in economy, business environment, and then the funds and financing drivers and the renewal, as we already discussed. Now the scenarios were made like this, looking at each of the drivers and looking at for each scenario, if that individual driver would have a negative event flow, then that would, be on the left on the graph. And if it would have a positive impact, that would be more towards the right of the graph in this respect. And this way, 6 different scenarios were, this is highlighting the most likely development reflected to the scenario. So there's a scenario at the bottom, and then the most likely development that the project team assessed according to the latest information based on all these drivers. But this is just an example. And by the way, on the right, top right, you see that in the legend that the purple marked drivers are the ones that actually define the scenario. So hence the naming and the reasoning for all of these. Now, looking at the 6 that we identified, going from the worst one on the left, multidimensional crisis, to the best one on the fast recovery on the right-hand side. So recession towards left, growth towards right, and without going into details, the most likely scenario that they saw was the slow recovery in the middle, stating that the COVID virus would sort of calm down during next year. However, the economic recovery would take another 2 to 4 years to get sort of back to normal. Then, well, the extreme ends, the multidimensional crisis and the fast recovery were not very likely, particularly the one on the right. The fast recovery seems sort of impossible. But there's a chance that we go left to a sort of stagnation in Finland, which would mean that we lose our cost competitiveness due to salary increases without any improvement in productivity, leading to labor market crisis, perhaps, yet to be seen. Funding and financing not competitive compared to other countries, and this creating a sort of a negative spiral locally and making the country less lucrative for further investments, then probably leading to investments being made elsewhere. Localization is one possible trend, where driven by the protectionism and thereby trying to localize the supply chains from global back to countries, and thereby making life more difficult for countries like Finland that are extremely export dependent. The best possible direction is to the right, and the one that we chose as a target was the scenario digital green acceleration next to the second to the right, from the right, which would mean that because of the strengths that we already have in digitalization, the strengths we have in low carbon technologies and the climate impact, all this together, and COVID giving a boost to the digitalization as well, this would lead to increasing demand in the areas where we have our strong bases, and that hopefully leading to positive structural changes and massive investments in these areas. This is a bit complex picture, but just to indicate how the drivers were combined to then identify each of the scenarios. So you see some what the defining criteria are. So the slow recovery, fast recovery, for example, very much dependent on the global trade and economy, like the localization as well, while some other scenarios are not dependent on what happens globally. That's maybe the biggest remark to make from this graph. Simplifying that a little bit, we saw that the most likely scenario would be the slow recovery, and there's a big danger that we move to the stagnation direction. But what we want to do is to go right to the digital green acceleration. Now, looking at the drivers, we notice that there are factors that are global on the horizontal axis, going from global recession to global growth. And there are factors that are much more local, where we have sort of the keys in our own hands. The vertical axis from local recession to local growth. and hence we realized that this is the axis that we should focus our activities on. So making sure that our activities are strengthening the driver development that would take us upwards in this picture, and at the same time take actions that would prevent us from going down. And that's basically the basis of our strategy moving forward. Now, if we are lucky, we get some help from the global demand and global economy going further to the right. If we are not lucky, we get some more burden from global, and hence having a risk of moving further to the left. So looks very scientific, but actually the way we sort of crystallize the end game is quite helpful. Now we know where to focus on. So what is the combination of the digital and green then that we looked at as the hopeful scenario here, combining these two strong trends. Digital leverages green in many ways. So looking at the digital, what do we mean by that from the sort of tech industry lenses point of view? It will be more value through digitalizing the business processes across the value chain, and there's a lot of efficiencies that we can gain from doing that. On the other hand, on the green side, what we want to accomplish is environmentally and socially sustainable business across the value chain, and primarily looking at the CO2 footprint and handprint that our industry has. And now that this trend is getting so strong, we see that there's a global demand for solutions that would help mitigating the trend. In the middle, we see a lot of areas where digital is a key enabler for the green activities, combining the two. So that would be our sweet spot where the two strong areas of the Finnish industry would be combined. And here's just a few examples of what would it mean in practice. Digitalizing the value chains in the industry, of course, has to do a lot with automation, robotics, autonomous systems, and so forth, supported with AI, digital twins, and all these technologies. While on the right-hand side, we would have renewable energy efficiency, electrification of everything. The use of electricity is seriously growing in the next few decades. The electricity consumption that we demand from tech industries is to double by 2050. So it's not an easy task to do. Circular economy was mentioned by Antti as well, and this is a key area where we see that we have solutions that we can contribute with. And in the middle, I mean, you might argue that everything should be in the middle, but basically all of these solutions that are on the chart, if you just think about how to make it more smart, like take circular economy, then and materials, material reuse, circular material use, that has to go hand in hand with data. You have to understand what materials you have and how it's moving forward in the circle, and moving from products to services, more digital business models, and digital processes, where the material impact is much more easy from environmental perspective. So overall, the overlap is much bigger than shown by this screen, but this is just to illustrate it. So boosting the industrial digitalization, and now I'm referring back to the graph that I showed, the assumed leading position that Finland has in terms of digital capabilities in our businesses. We have a number of smart industry initiatives already in technology industry in Finland. We have initiatives like the Advanced Manufacturing Network. We have our AI accelerator helping companies. We have DMEC as the high-tech ecosystem co-creation platform, looking at initiatives like the industrial data excellence. We have a number of Business Finland programs like the Sustainable Manufacturing Program, PTT universities. They all have a lot of initiatives here. A lot of it is sort of techie technological stuff where the industrial manufacturing will be automated and made much more smart using all these technologies that we are happy to play with in the industry, but also creating new services on top of the products, which is really important trend, servitization, and purely new business models as well on top of the product manufacturing business. What is key to note is that because of the structure of the country, I mean, we have a huge number of very small businesses. Their ecosystem play is really critical. How do we make research institutions like VTT, universities work together with big companies, work together with small companies? We need big driver companies to drive these ecosystems, and then supported by small and startups and academia. This is really key when it comes to boosting our industrial digitalization. Now, looking at the green side of things, there's two different views to that. One is minimizing our CO2 footprint, and the other one is maximizing our impact. Here's the graph, and I'm sorry for the language. It's in Finnish only, but if you look at the graph, the blue area that goes down most is metals production, so steel makers, and the majority that would come from a single project by SSAB, where they changed the way they replaced coking coal in the steel making process, and replacing that with electrical furnace which is based on hydrogen use instead of coal. So becoming basically carbon neutral, or virtually no carbon footprint from the overall process, which is a remarkable reduction. That single event would decrease actually represents 7% of total Finnish CO2 emissions today, and when that goes to zero by 2035, hopefully, or 2040, that would have a really big impact on the carbon footprint of our industries. What we need to accomplish this is a level playing field, and this is becomes really complex and political in EU and globally, because we tend to have much stricter rules and requirements in EU compared to other areas of the world, and we tend to be far ahead actually in the Nordic countries compared to the rest of Europe, looking at how environmentally friendly our production processes are. So hence, to make sure that the clean solutions are successful on the market, we should make sure that the other imported solutions are not subsidized by with different rules of the game, so to say. If we have a level playing field, we'll succeed. Now, maximizing the handprint, as I said, is much more important than the footprint. The handprint, meaning that the technologies that we bring to the global market, whereby the other users of our technology can reduce their footprint. And according to the analysis made in our low carbon roadmap, it indicates that the handprint of our current export products and technologies is already about 20 million tons of CO2 per year. Now, to put this in perspective, the total emissions of Finland as a whole is 53 million at the moment. So the handprint of our technologies today is 20, and it has a potential to grow up to 70 if you include also the products under development at the moment, like the one that I mentioned with SSAB. It's a massive technology export opportunity that we need to grab, but we just need to have a level playing field and then make our investments right and ensure the focus on digital and focus on climate. This is clearly stated in the EU budget and the EU Recovery and Resilience Facility, but we have our fears that when the money is being spread across EU, then who knows where it's spent on, what it is actually finally spent on. We hope that the focus will remain. We would like to have fair access to all these development programs because there's a lot of development with heavy stimulus packages being done across Europe. If those programs would be available for Finnish companies as well, that would be a big opportunity for us. Just quickly to make this a bit more concrete, some existing and future handprint technologies. On the right, SSAB, what I already mentioned, CO2 neutral steel would be available 2035 in Finland. And that single solution will reduce the Finnish CO2 footprint by 7% from what it is today. But there's very well established good old technologies that we had for a long time already. So take like the ABB speed and frequency drives that optimize electric motors. 60 to 70% of electricity in industrial use is spent on electrical engines. By equipping them with the ABB type of drives, would reduce the electricity consumption by as much as 50% per engine. So if you then think about bringing this to every engine in globally, that would have a dramatic impact. The automotive electric cars and batteries an obvious one, so I'll just skip that. But take Cargotec electric cranes, for example. There's an estimate that, for example, the Kalmar cranes built in 2008 to 2018, only that subset of the products has an CO2 impact equivalent to 3 million tons. Autotech metals processing solutions the handprint is 6.6 megatons per year, if I remember correctly. And well, Vahterus is a small, medium-sized company doing heat exchangers, having a very niche global market for that patented solution for heat transmitting in a very special way for chemical processes, energy processes, and refrigeration. These are all solutions, apart from the one on the right, these are all existing and all having a very remarkable impact on reducing CO2 emissions wherever they get into use. So this is really critical that we get more of this and are able to innovate new solutions on this scale. Finally, what do we need to succeed? Apart from a bit of luck and money, using the same framework that we already looked at, the tech company in the middle and the surrounding drivers then listed in these four corners. We need to have, well, hopefully COVID will be managed in a way that we don't get any health disaster. On the renewal front, we need to make sure that our skills and education are world class in Finland. We need to have much more fluent immigration of highly educated people. I mean, there's people lining up to Finland, but I just don't get it why the processes are so complex that it's so difficult to get those in the country. And we have to make sure that everybody who graduates from Aalto stays in Finland, at least is giving the opportunity to work in the Finnish tech industry companies. Global trade and economy, we need, as mentioned, level playing field. We need World Trade Organization, free trade agreements in place, and WTO also to look after the level playing field. Regulation, making sure that we don't have different rules of the game in China and in Asia than in Europe. From EU, we need consistency in the policy and regulation. And EU single market, that's very important for a small country for us, like ourselves. We absolutely want to avoid any protectionist activity and keep borders open and make sure that the export and import within EU is smooth and will continue and grow. When it comes to the local business environment, we need some flexibility and local agreement on the cost of work issue, because we are more expensive in Finland than in the relevant competing countries. We need predictable regulation, of course, level playing field. We need a national industry strategy, which we, by the way...
Jaakko, we are a little bit losing your voice at the moment. We can only partly hear it.
Oh, thanks for saying. Is it better now if I just try to keep the mic a bit different?
Yes, now it's better.
Okay, okay. Sorry for that. In terms of the bottom right corner, we absolutely don't want any additional cost or tax on the Finnish companies. So this is a clear message for the government. But however, we need increased research, development, and innovation funding, and make sure that the EU funds are allocated right, not to support rural areas in very rural Eastern European locations or whatever. Rather spend the money something that builds the future for EU. And we need electricity, a lot of electricity at the competitive price. What the tech company has to have in place, they have to have the courage to make investments and have a growth mindset. And understand the ecosystem importance, play with partners, play with the academia, and not try to win the world alone. And we need to have employee trust, trust in place locally to make sure that there's everybody has a feeling that we are in the same boat. Finally, this is my last one. I just include this in most of my presentations because I just want to remind people of the very simple formula presented by Matti Pohjola. Where is the high level of standard of living coming from? Mathematically, GDP per capita is productivity times work amount. And if you look at the work amount, like what we do, whether we work 6 hours a day or 8 hours or 12 hours, how many people do we have, what is our employment rate? Well, that is very important, but the impact and the growth potential is a couple of %. Now, theoretically, productivity, which is all about the knowledge, skills, and research, innovation, and so forth, carries an unlimited growth potential that we need to grab. And that's where our focus should be, looking at the ways we can do that far better than before. So in conclusion, trying to go to the favorite option of a digital green future, which is a challenging ride, but that's where we want to place our bets on. Make sure that the Finnish very much technology focused industries is succeeding in the future as well. Thank you.
Thank you very much, Jaakko. We had a little bit voice problems in the end, but only in the end. But you had very clear slides as well, so we didn't miss the points, I think. And I think one of the key points when I was listening to you, you had a very strong message, and I think one of the key points what we listeners started to think is that how important it is that we are able to create this kind of circumstances and possibilities for the technology industries in Finland in order to succeed in this global competition. I know that this is a little bit sensitive question, Jaakko, but I still have to ask you about it. Thinking about this issue, what you just lectured to all of us, how well our political decision makers are hearing your messages?
We have a challenge. We have a challenge with the decision makers at the moment. I must, well, between you and me, I mean, if we agree that this stays in this room, the understanding of our current politicians and decision makers, the government, understanding of the importance of the industry could be better. Mm-hmm. But on the other hand, we have some very positive signs, like what we are doing together with the Ministry of Economic Affairs is very positive. We have a lot of good initiatives moving forward together with them. So I'm hopeful again.
That's good. That's good. Hey, we are a little bit almost running out of time, but one more question to you, Jaakko. Thank you once again for your very, very good lecture. I know that you are in your position following carefully what is happening globally also in this technology field. And we can read from the news that this technology battle, especially between the United States and China, is getting harder. Is that good or bad for our technological companies in Finland?
Well, competition is always welcome. Of course, when it becomes hostile, like it seems to be between the US and China, it's not positive for anyone. But as long as the competition is fair, it's more than welcome. Europe is lagging behind in many areas, as we discussed, but it's mainly in the B2C area, as I noted. So when it comes to industrial success in the future, I think Europe has a very good chance. I just had a good meeting with our German friends and the German Chamber of Commerce earlier today, where we discussed the possibility of combining the very strong industrial capabilities of Germany with the strengths of Finland, which are pretty much based on the digitalization and the clean technologies that we discussed here. That we believe, and our German colleagues believe, that that will be a winning combination. So if we get it done right and are able to cooperate across borders within Europe in the single market environment, we are quite strongly positioned, I believe.
Very good. Hey, thank you once again, Jaakko, for your lecture. Thank you also, Antti. I can still see that you are online, and thank you, Antti, for answering the questions and comments in the chat.
My pleasure.
We will continue after 1 week, and next week we will actually be talking about artificial intelligence. Antti Merilehto will give a lecture about artificial intelligence, and then Meeri Haataja will give a second lecture next week, discussing and lecturing about the ethical aspects of the artificial intelligence. Thank you for attending this week Aalto University's public lecture series, The Future of Technology and Finland. Stay healthy, and we will see and come back in 1 week. Thank you.